Buenos días. Mi nombre es Francesco Pinto. Bonjour, je m'appelle Frank Pinto. Hello, welcome to TechEd 2013. Woo. My name is Frank Pinto. I'm a senior consultant with Microsoft. I'd like to introduce Alfred Ojukwu.
Come on, everybody wake up. First session.
Yeah!
We're excited to be here.
So now that we've got the formal introductions out of the way, we'd like to introduce ourselves with what everyone else calls us. My name is Shaft, introducing Kojak.
Who loves you, baby?
All right, so let's first start off with a little bit of a survey. This is the third time we've delivered this session, and we have brand spanking new content, brand spanking new demos for this particular session. We got a lot of good feedback, and we have some feedback about more details here and there, so we've integrated that in. But let's, in fact, so brand new that please wait about an hour after the session to download the latest content from Channel 9. Brand spanking new. So, by show of hands, who currently is deploying in their corporate environments to UEFI? Okay. And those of you that are deploying UEFI, do you feel that you have a good understanding of something called secure boot? Show of hands, if you feel that you do. Okay, great. So you're going to learn all about that in this session. I won't go over piece by piece what's on the agenda here, but we'll just dive right in and give you guys the kind of content you're looking for. Alfred, anything to add?
No, I think he turned us down. That's okay. The important thing is, we're covering UEFI in detail, just making sure you guys have a full understanding of what it is and what you're being provided with this solution. Michael Niehaus covers Windows 8 deployment in its holistic form, and much of it talks about, UEFI has a small portion of it. We kind of blow it out and give you the full details. So we'll start off with what is UEFI. So for those of you that are not familiar with UEFI, it is the replacement to BIOS. So BIOS has been around for some years now. Many of you guys have systems that are running on BIOS. You've basically made a career out of it, which is great. But something that happened recently with some of the changes with technology is the need to transform to a newer platform, a newer firmware. So UEFI is a firmware specification. And again, the important thing to note is that it is there to allow us to provide a much more secure platform to load our OS in. So in the early, I believe in 2000s or so, in Windows 2000, right? So around the time that Intel and HP decided to introduce EFI as a new firmware, it stands for Extensible Firmware Interface. What they did was to rewrite the firmware platform so that it could support the 64-bit. Again, initially, it was called the Intel Boot Initiative, and eventually it became transformed over to UEFI when it was passed over to a forum, the Unified Extensible Firmware Interface. And now it's owned by the UEFI forum, but again, it's there to ensure that it's providing support for the newer hardware. Originally, it was there for the Itanium platform, and over time, as it developed in 2005, and they secured it for UEFI 2.0, UEFI 2.1, it then became available for other platforms other than just Itanium systems.
So putting the U in UEFI.
Yes. So the beauty of this is that a lot of the changes that we'll be talking about as we go through these slides is the fact that it addresses things like writing in higher level code, ensuring that you have a faster boot time, using larger buffer IOs than it has in the past. So another way to find out more about it is the UEFI.org site has information that tells you more about the organizations that are part of it. Many of you work for these companies that exist here. Obviously, we here work with Microsoft, and all of the forums are involved in ensuring that there is a specification that's been provided for UEFI. That specification allows us to standardize what's available in that platform. So things like drivers, writing option ROMs that are going to be available on those systems. This forum is basically the guiding the guiding principles around how those things are provided. Again, UEFI is a specification and not a hardware of any nature. So tons of documentation that you can actually go through on their website. I would, if you have the time and you're really interested, go ahead and go through them. Did you have anything to add?
Yeah, I think so. It's important to notice all the different vendors that are on the screen. And what's really important is that when EFI was first introduced, it was proprietary. It was made by a hardware manufacturer for their equipment. So now, when we think about UEFI, we have to understand that it's modular, and it goes across multiple devices. You can plug and pull out individual pieces for UEFI, and there's nothing that's proprietary for UEFI. And that's why we have such a large consortium of basically every major vendor, hardware OEM in the globe.
So why is UEFI important? So number one reason UEFI is important is it enables innovation. The idea that now you don't have to rely on an older BIOS-based firmware that relies on 16-bit real mode or any of those older technologies and written in assembly code. Some of you may have already been writing in assembly code. UEFI is basically allowing you to sort of utilize that newer platform and newer firmware interface to do what you need to do.
Show of hands, anyone write assembly? Wow, all right.
Are you
See
bummed?
me after the presentation.
Beauty, again, is that you can write in C code. It moves much quicker. And for many of you that may be aware of this, there's a support for a larger disk size. So 2.2 terabytes was the limit that MBR had. So with these larger disk size that are being provided and utilized, it requires the use of UEFI to actually boot to them. And no longer can you use those MBR disks that you had before. And in addition to that, you have the CPU-independent architecture again. See, the idea again is that you no longer have to worry about 16-bit real mode. You can now move up into the 32-bit and 64-bit architecture and not rely on those requirements as a limitation. And the flexible pre-OS environment, you have the ability to now get into that framework and use the mouse as much as possible, whereas before you had to go through that quirky little screen options in BIOS to make what you needed to do what you needed to do on that firmware platform. And lastly, the modular design in terms of what's available in that pre-OS environment. The one thing that we want to stress is that UEFI, the firmware platform, is pretty much like an OS. It's basically built off of an OS platform where you can actually load drivers. You have the ability to kind of do, it's sort of a mini OS now, whereas the BIOS didn't have that sort of framework. This gives you that extensibility of controlling what's in that location. However, it's not an OS. So we talk about 4 different types of software. We talk about the OS itself as being a software. We talk about the BIOS, the BIOS itself being a software, or the firmware itself being a software, the applications being a software, and the process of how that actually gets up to the use of the application itself. We'll go into that in a few slides here.
The modular design is also important because it will enable us as we create new features within UEFI. We're able to plug those new features in without having to completely revamp and update the standing BIOS, as we would have to flash every single time. The fact that it's modular allows us to plug these pieces in. So current standards, we have some support standards for UEFI. And we're providing you this information up and early so that you're aware of it. With UEFI, we're moving away from, as we move to a higher level platforms, Windows 2008, Windows 2012, you see the support begins to improve. So with 2008, you had support for booting 64-bit systems with UEFI, and the scenario varied in terms of what was available. You couldn't boot 32-bit systems on there. You had to boot 64-bit systems. And so many of you probably have infrastructures that run with Windows Server 2008, R2. So those will support your 64-bit systems. The recommendation, as you can see here, is to move to a platform that supports both x86 and x64. Windows Server 2012 provides that level of support so that
regardless of whether you're providing images that are for 64-bit systems or 32-bit systems, that support's built in. In addition to that, UEFI provides support for IPv6 based requirements on 2012 as well. So again, the other piece that we've mentioned, and you may have heard Niehaus mention this as well, is that you have to have the right platform to boot to the UEFI. So if you're building 64-bit systems, you're going to have a 64-bit boot image, and if you're building 32-bit systems, you're going to have to need a 32-bit boot image. Again, that distinction is very important because now you have to manage your images separately as one instance.
Okay, so with regards to UEFI, there are multiple classes of UEFI, and it's important to understand what each is. Class 0. Class 0 is what is known as the legacy BIOS. Literally BIOS and BIOS alone, and there's nothing else. That's Class 0. When we move to Class 1, Class 1 is actually UEFI and BIOS, but it only allows the BIOS to run. It uses something called CSM, the Compatibility Support Module. So even though UEFI is on that system, it can only operate in a BIOS mode. When we get into Class 2 is when we start getting flexible. Now, Class 2, your hardware that's already in your infrastructure in the, say, 2 to 3 years old and newer range, more than likely will be Class 2 hardware. Class 2 enables you to run in UEFI native mode, so you're able to switch. You can be in CSM or you can be in native mode. And then Class 3, good examples of Class 3 are some of the new tablets like our Surface. They are strictly UEFI, so there is no CSM mode that you can run in. Now another bit is that there are different versions. So we have classes of UEFI, we've just identified those, and then we have different versions of UEFI firmware. Now the UEFI firmware, it's important to understand that you should be using version 2.3.1 or newer to take advantage of the majority of the features that we've discussed in the presentation.
And so just to add a few things to that as well, with Windows 8, all the systems are coming out with Class 3, which provides you with the ability to have secure boot. Now, secure boot, again, we'll mention this later, is not a feature of Windows 8. It's a feature that's provided as a UEFI specification. And Class 3 comes with that opportunity. The other piece is the Class 1. If you think about when EFI was first developed, a lot of those systems were based on the pre-EFI platform that supported Itanium. And so if you have older systems, they might have the ability to use that EFI version, but you really don't want to use that. You really want to look for systems that support the Class 3 systems.
With version 2.3.1 or newer.
Okay, so we're going to keep moving forward. We've talked about a little bit about what UEFI is. So this, again, goes into the architecture, the underlying architecture of what the firmware looks like, how it's being evolved into a newer platform. In order to make older systems work the way they need to, they've built into it the ability to access the legacy BIOS. We mentioned the CSM, or the compatibility support module. What it does is it emulates the BIOS so that it can actually allow you to utilize that as part of your boot process. So if you have a system that still relies on the old legacy BIOS, it will still work on a UEFI-based system. And at some point when you're ready to switch over from Windows 7 to a Windows 8 system, that EFI will kick in and allow you to use that as a partition. Again, with the Surface Pro, we're going to stay with the Windows 8 and the EFI. You will not have the ability to kind of switch back. The only option you'll have is to remove the secure boot if you need to fix or resolve an issue. To give you a better flow, we talked about different types of software that runs in the system. This gives you where that firmware sits in that framework. We talk about the fact that it's passing information from a lower level hardware up to the higher level software. The firmware is that interface. It's that piece. So the BIOS also fit that framework. The UEFI fit that framework. And its job is to ensure that communication happens efficiently. It passes that data about what keyboard you're plugging into, the drivers that you're loading, those video drivers that you're loading, that they're available. and it moves it it passes it over to the bootloader, which then starts up the operating system. Once that's done, it literally lets go and allows it to run that operating system until those applications are up and running. Again, the important piece is to get to your applications in a much more secure and much more swift process. And this basically lays out that process for you guys, making sure you understand what's happening underneath the surface of your application, your systems themselves. And to give you a little bit more detail, I won't go over this whole slide, but I want to give you sort of the important pieces here. This is your UEFI boot process. This is what changes between the BIOS and the UEFI. We talk about the fact that you're moving from a pre-verification stage. You're still having your power on self-test, which actually kicks in as well on the BIOS. But you can do all your initialization during the pre-EFI stage, and then it passes it over and starts loading drivers. Again, something that we couldn't do in BIOS. We're now loading drivers to have it written in drivers so that it understands that higher level language.
Digitally signed drivers.
Digitally signed drivers as well. And then it goes through that process of ensuring that it can get to that boot manager. Once it gets to that boot manager, it looks at the partition. It's looking for that GPT partition, which we'll talk about. And once it finds it, looks for the grid where that bootloader is located and passes it off to that bootloader. If you have UEFI shell or any of those, the EFI shell, you can access that and make changes as needed in that framework in the SDK itself. And it will pass it over to the bootloader, and it does an exit. From that point, it's the job of the UEFI environment is pretty much done. It just remains dormant until you need to hibernate your system or pass lower level code up to the application of the operating system. Okay, we've covered the UEFI boot process. We've talked about where UEFI came from, how it is where it is, but we haven't really talked about why it works the way it does and the underlying disk that it relies on. How many people have worked with GPT disks generally? Okay, good.
Number.
So for those of you that haven't worked with GPT disks, get there. It's really a much faster, much more secure, much more controlled disk environment that you can use. It allows you to ensure that you have a reliability on your disk, and if there's a corruption occurs, you still have the ability to have your disk come up without any problems. The change in the grid partition table allows UEFI to do what it needs to do in terms of finding that partition and utilizing things like FAT32, which is part of the GPT layout, and it also allows you to ensure that you can have a much higher level of partitions, so up to 128 partitions. Whereas MBR gave you 4 different partitions, you now can use 128 partitions. And in addition to that, you can support up to 9.4 zettabytes.
Zettabytes.
Okay, zettabytes. That's in terms of size. The primary goal of the GPT disk for UEFI is so that you can utilize disks that are larger than 2.2 terabytes. So this, I feel, covers that as a solution. So again, as you're deploying your systems, remember that if you have systems that are running MBR and you're moving to Windows 8 and you're moving to UEFI, those systems will be formatted to utilize the UEFI and the GPT disk by default. If you have a Windows 8 CD that's just basically Windows 8, it will, and you stick it in your system and you start running it and you say, I want a Windows 8 system, it will check on your device to see if it's UEFI capable. If it is UEFI capable, it will then look to format that disk so that it supports the GPT format. And from then on, all your data is wiped. So USMT becomes your friend, which we'll talk about later.
Okay, so we're going to jump into some UEFI refresh scenarios. We just want to put a picture up here so that you could get the idea. We just talked about if your system detects, if Windows Install detects that your system is UEFI capable, it will go ahead and install it in that method. However, there's a caveat, and it's an important one. On the screen that you'll see with the UEFI Legacy boot, you see that it says both. So that's what we were talking about earlier. We have the Class 2 systems where you're able to do UEFI native or CSM. If you're not in UEFI native mode, you will not install utilizing UEFI. You must be in UEFI native. So that's an important thing to remember.
So and just for this image here, a lot of manufacturers have different, configurations on in the firmware interface. So be sure that you're fairly familiar with how to get around, because Dell has a different view, Lenovo has a different view. All of them have separate commands that you can use to get to the security settings or the UEFI configurations. Again, if you're booting new Windows 8 systems, you'll notice that they'll come by default configured for UEFI as the default mode.
Recently, manufacturers have started doing that. So this is, we're talking recently in, say, the last year, they've started sending things in the native UEFI mode. But if you're in a refresh scenario where you have hardware that's already been deployed, more than likely you're running both, or also known as CSM. Now, this is difficult for us that manage, thousands and hundreds of thousands of machines. Do we have to touch every single device to change this over to UEFI native mode? Because it's so different by manufacturer, if you check with each individual manufacturer, they do have scripts that can provide you an automated way to change the BIOS mode into native mode. Almost every major hardware vendor will provide you with those scripts.
Right. That's another question we had before, is how do we automate the process of ensuring the systems are UEFI capable if they're not set that way previously? So make sure you're talking to your vendors, make sure you're talking to the folks that provide you the hardware to ensure that they have that script, or the other option is to work with them to develop something that can go into your deployment solution, whether it's MDT, whether it's Configuration Manager, whether it's SneakerNet.
Okay, so we'll talk about configuring partitions. This is the current best practice as recommended by Microsoft. So you'll see that there are 4 partitions there. We have the Windows RE tools. Show of hands, anyone familiar with Windows RE tools? Okay, so the WinRE tools is basically the tool set that gives you, for those who are not familiar, gives you the ability to do things like repair the startup menu, repair the startup files, run scan disk, do antivirus scans. All of the administrative type functions are built into WinRE. So we build a partition for WinRE, and we strongly recommend that you use that partition and you implement WinRE. This will really help as we have more and more users transitioning to laptops from the field, if a technician is able to teach them in just a couple short steps how to automatically repair problems that occur while they're in the field. Then we have our system partition. And the system partition is what holds the UEFI files. This is our protected partition that keeps the EFI files, which boot any operating system that is utilizing UEFI on the machine. Then we have the MSR. So the MSR stands for the Microsoft Reserve Partition, and what that is a partition that's designed to manage disks. It's a very small partition, but when you're loading Windows, you'll see that MSR will be put there by default. And then we have our Windows partition. So then that is exactly where we place Windows. So now we're used to seeing that single partition if we're under 2.2 terabytes on our disks. We're used to seeing that 2.2 terabytes on our disks. We're used to seeing just that single partition. And now we have these 4 separate partitions. If you just go by default and you install from the media, we'll actually show you a screen, it will only create the 3. And the 3 that it will create is the system, the MSR, and the Windows partition. We recommend that you go in there and you create the WinRE as well. Yeah,
or you use your deployment solution to configure it to do so. So we get a lot of questions. We get a lot of questions from the field. So just to give you guys a quick background of what we do, I'm from New York, and we work with a lot of customers in the New York area that ask questions. They want to know how things work. And one of the things that we get questions on is, can I delete these partitions? Why do I need all these extra partitions? do not delete the partitions.
They're a little important.
If you have users that want to delete it, do not let them do it. It's very important.
If you want your system to run. Okay, so then if you'd like to add a recovery image, lately more and more of my clients, I also work for MCS, so I'm out in the field working with large organizations helping them deploy Windows. Something that's coming up more and more often now is that we're being asked to create an additional partition where we have a recovery image built onto the system. So
how many people have that scenario where they need to have recovery images available? Right, and we know how important that is. If you're out in the field and you're not connected to the network, you have an image that goes down, you need that recovery image to come up right away. So,
with the evolution of keeping users not only files synchronized in some cloud location, but now we're able to keep users settings synchronized in cloud locations. This is really, really becoming a popular topic, and I can't think of the last engagement that I performed where a customer has not had me design this in.
So those two options, I mean, again, the key, there are other things that you can add to your partitions, like BitLocker. Where would you actually have your BitLocker? You know, you can actually use one of the partitions to have BitLocker stored on there as well. So also very important to think about whenever you are working with your systems. All right, so we're going to keep moving here. We talked about the partitions. We talked about GPTs. Now we want to get into sort of what you need to do when you're thinking about deploying UEFI. That reminds me of a book I used to read. What I think about when I think about running. So let's talk about this a little bit. So first of all, there's multiple ways to create your UEFI disk or your Windows 8 deployment disk. We've listed a few of them here. Option one, you can break up that WIM file because again, if you're using a tool like MDT or Configuration Manager, that WIM file may not fit into a single USB if you're using a USB. So again, because UEFI requires a FAT32, which I'll talk about in a second, you may not be able to fit it into a single key. You might have to split it up. So an option that you have is to work through configuring it so that you can actually read to multiple keys or multiple USB drives if you don't have any other option. And that also in MDT may require you to go in and make some additional changes to your script file so that it ensures that it can actually read that SWIM file wherever it is. Now with MDT 2012 Update 1, that has not been updated yet. However, that's something that's being taken in as feedback, and hopefully within some time we'll have it updated so that you can actually build your images using SWIM files. But that is an option that you can create if you're really super uber excited and want to get it going with SWIM files.
Anyone uber excited? I am.
Hey, they're still awake. So you can also create multiple partitions. So Windows to Go, again, how many people have Windows to Go devices? Very cool. I love it. I use one too. They come in different form factors. I like the ones that have hard disks, basic hard disks. I don't like the ones that, that are just sticks, but they're great. They work just the same. Windows to Go devices act as, partitions that are fixed disks, so you can actually create multiple partitions on it. Again, a requirement for UEFI is to have a FAT32 and an NTFS partition. So if you have a Windows to Go device, you no longer have the need to just use a USB key. You can have a device that can load FAT32 and load NTFS and kind of move forward with deploying your image. You'll see that in the demo here as well. You can, and I mentioned that earlier as well, to create your image using two USB sticks. So you would format one as an FTFS partition, and you'd format a second one as a FAT32 partition. Now, if that, the FAT32 will end up being less than 2 meg, either 2 megs or 200 megs or 400 megs. Make sure that it's big enough so they can actually support what you need to do. Mm-hmm. And then, again, with Windows 8, you can actually deploy it using that CD. Two pieces that I haven't mentioned on here, obvious ones, is just deploying it through the Pixie options or network boot options. Those are also available if you have Windows Server 2012 or even 2008 for 64-bit systems. It takes a little bit of work, though. Okay, next slide. All right. Here's a script, a sample script of this part. This is a full holistic process. and we'll come right back to this. This basically shows you what you'd want to do if you're going to partition a disk. I'm going to jump over to a screen, and we're going to actually walk through the process of using diskpart. Now, go ahead and switch screens, please.
These are tricky. These switch boxes, boy.
All right, so I have a system here. I've plugged in 2 disks. I'm going to have one I have one that's, I believe, 4 gigs. And a second one that I'll put in here. So what we want to do is we're going to format one of them as NTFS, one of them as a FAT32, and we'll make sure that our media is available on those systems. That's the first step, is to ensuring that you have the right set of disks for what you need to do. So I'm going to CMD, open up a command prompt, and diskpart is your friend, right? Very simple. I can have a script do this, but again, for those of you that are just looking to ensure that your disks work the way you want, we're going to go ahead and list the disks that are available. You see here, my normal disks here are, I have a 149 gig disk, and the ones I care about is this 1.9 gig disk and this 4 gig disk here. I'm going to go ahead and select disk 3. And first thing you're going to do is you're going to clean that disk, right? So you're going to wipe it clean. So now you're going to go back in and format it as
FAT32.
FAT32.
Hey, I guessed it. Do I get a prize? By the way, for those of you who stay to the end of the session, we are giving away a brand new car as part of this session. See us after the session, approximately 10 minutes after the session's over. We should still be here. Just come up and check with us.
All right, I'm going to do one step different. I'm going to create a primary partition. So create a primary partition. And you notice I'm not writing the whole list here. But I'm going to create it as a primary partition. And then I'm going to format it. Format fs equals FAT32. And again, the purpose is to ensure that I can actually install the...
Use it as a boot.
Exactly.
For UEFI. Because it must be FAT32.
So from there, it gets formatted as a FAT32. That's the start. So again, I'm creating a 2-disk process to ensure that I can actually boot USB. This isn't anything complicated for a whole lot of people out there, but it's to ensure that you understand why we need it. And then I'm going to make this an active disk. So the boot disk is going to be the active one. And I'm going to assign it a letter. And from there, now I have my boot disk that's available. And I can actually, so before I finish, I'm going to go back in here, and I'm going to do the same thing for this second disk, but I'm going to format it as NTFS, but I won't make it an active disk. So let's go ahead and do that now. So cell disk 1, or cell disk 2, right? And then I'm going to clean that.
No, go ahead and do disk 1. Let's see how that works.
Okay, so I've gone ahead and removed everything from disk 2, and then from there I'm going to, again, create a primary partition. I'm fairly lazy. I don't like writing out the whole line. It just takes too much time, right? Yeah, fs equals NTFS. And this one I'm going to label as deploy. Now, this scenario is important when you're using media for deployment, right? So if you're using MDT media for deployment, this becomes a huge benefit. It speeds things up. You have all of your MDT files in that same location. For all intents and purposes, I've already gone ahead and done that. So on my disk myself, on here, I already have a media location with my content that's been pre-created. So I have a boot folder, a deploy folder, UEFI, and the auto runs. Again, the key here, the difference is that this file itself will be much larger than you probably expect, and this is what's going to limit you from having it on a single disk, that deploy folder. So what we recommend to folks is that second disk that you have as NTFS, you'd actually want to move it into your NTFS partition, or NTFS partition that you created.
As you can see here, I'm going to show you this, but you guys are going to crack up. I have a 2 gig boot disk, and I have a 4 gig boot disk. What's the problem? Anybody know the problem? My deploy folder is 4.2 gigs, so what happens if
Hey, we have the winner for the car. Congratulations. Yes.
This isn't, again. He says he flies everywhere. Okay, so that's important. Make sure your disks are big enough. Make sure that you have the right partitions available. But I'll walk you through it. But again, it's just so that you understand what we're doing and why we're doing it. And from here, what happens is I'm going to now copy the boot file, the EFI file, auto-run, boot manager, and boot manager EFI. Again, all these files are important, and I'll explain why in just a second. Let's just start the copy over. So let's take a look at the file. In the EFI directory, we talked about that. There's a Microsoft directory that's basically there to ensure that that we can actually boot up. So EFI relies on this. It has to find that FAT32, and it has to use that to ensure that it can actually do the boot, the load of the actual pre-OS environment, the firmware, and then a backup for the boot. And again, last thing we want to do on this folder is in the deploy folder. I'm sorry. Should have copied over. Let me go back over to my boot folder, and then I'm going to create a deploy folder. And in that deploy folder, what I will do is I will also add one more folder, the boot folder, right? So I'm going to take that boot folder under deploy in the original location, and I'm going to drop it in the deploy folder on the USB key that I created.
And so this is the USB key that's formatted as FAT32?
Correct.
So this is our boot USB key.
This is my boot USB key.
Okay.
The deploy USB key is, I consider it the overflow key, right?
Okay.
So we're going to go through and create that. And so what happens now is, once you're completed and you've started copying over the deploy key, you're going to end up with a completed copy of a FAT32 and NTFS disk partition that you can then use on your systems. Key point being, you must have at least 2 USB keys to make this work. If you have one USB key, like you do on the Surface, you might have some problems. You might have to get...
USB port.
There you go. Those work too.
So is this any different with Windows to Go certified drives?
Absolutely. That's where I'm going next.
Oh, amazing.
So as this finishes up, the next piece of it is to save time. Again, this is why we kept recommending get those Windows to Go devices, because you can have multiple partitions. If you're not using Pixie Boot, if you're not using some sort of network reliable solution for deploying Windows 8 for UEFI, this is your next best option.
This is something that's currently being worked on. So when we're looking at these class 3 devices like our Surface, there's a lot of machines that don't have integrated NICs, and so we have these 2-stage drivers that have to be put into the boot, that have to be put into your boot solution, right? So we'll have a USB driver, and then we'll have the network driver. So a way to get around that while the industry is catching up and providing us these types of 2-stage drivers that we can use in a pre-OS environment, the way to get around that is by using these USB sticks, right?
That is correct.
Oh, thank you.
Okay, so we're going to keep moving forward. I have 3 USB ports, so I'm going to go and plug this in. This is already completed. It's already done with this step, and we'll show you what the disks look like. The fact that we've already have a FAT32 and an NTFS partition created. Your disk layout will already have been formatted that way, and you can literally move forward into actually creating your new image. Okay, so I have a boot partition here and a deploy partition, and you can tell the difference. The Windows to Go device is a fixed disk. It shows up as a fixed disk. And again, same files are here. I have my boot deploy. Everything is just the same. I've got a hidden partition for a Microsoft IT. Very cool. And just take care of this here. In my deploy folder, I have the same thing where every other file is there located that I need. So all the system files are there, and I can actually move forward with the process. So this is essentially what you create either way. You're going to have to copy the files over.
Okay, let's jump back in. So what you're going to see, we just wanted to provide you with an image of what you would see. If you do actually, I do have some customers that deploy, although I don't recommend this, but it's done, that deploy using the Windows 8 media, if you will, say from a USB key, and they customize the auto on a 10 file that's in there. And as you're getting into Windows, if you were to expand out the drives, you would see these are the 3 partitions that are created. So we talked about this before. What is the current recommended practice, right? Which there is how many partitions missing from this screen based on what we talked about before. Just yell it out if you know it. 1 partition missing that we recommend. 2.
I see 2. He's got 2.
2 if you'd like to add the recovery image as well. Okay? So you would want to, in this case, if you were going to be utilizing that method to deploy Windows, you'd want to customize that auto on a 10 file using that script or some other method if you would like to customize your XML stuff yourself. This is what it could look like.
Windows 8.
Oh, I'm sorry, within Windows 8, yes. This is what it could look like within Windows 8.
All right, so we're going to go back to demo. We're going to keep moving forward. Before we get into MDT 2012, this guy.
Okay.
So what we have here next on the screen is my Dell XPS 12 system. So the challenge with demoing this with a live system is we can't really connect the system to show you the pre-OS environment. So it's very important for us to kind of give you that framework so that you can see what's actually happening as you actually boot up. Now, I'm going to go ahead and boot this up. But first, let's look at what we'll see if you have basically Windows 8 system that you're actually loading up. So I have this 8 gig USB stick and my Dell XPS 12. I'll go ahead and turn it on. Now, I'm going to have to open this. I don't know how that works. Okay.
So here there's... Oh, mic's not on. I want to talk about the Windows 8.1. So here within Windows 8.1, we might be able to demo this a little more smoothly.
Yes. So the reason why we're doing this right now is because if you look at what you have for virtualization, a lot of the systems that we have for the Microsoft current version of VHDs really do not allow for the virtualization of UEFI because of the fact that they don't support the GPT disk, right? Right now they support MBR disks. As we are upon the release of Windows 8.1, you'll see what we call the Generation 2 VHDs, and those will support the UEFI GPT format. They'll be much faster disks, so you can literally have fun with your disk that are UEFI supported on the Windows 8.1 platform. So within
that'll
days,
make it a lot easier to do your testing, your troubleshooting, and your image building now that we're able to actually support UEFI in the virtual world, in the Microsoft virtual world.
Exactly. So let's go ahead and boot this up. Now, all the systems are different. This one relies on F12. And if required, you're going to need to, as it's coming up, go ahead and select your boot device. But it's also probably important. Oh, there's my SanDisk cruiser. Hopefully you guys can see that. Can everybody see that screen? Or is it kind of dark? Dark? Light. Much better? Why are you spinning? Get out.
Auto zoom.
This is my second time using this, so I have an excuse. So I'm going to go boot to my USB device.
So what are we going to see when we boot to the USB device?
So what we'll see as it boots up is your normal Windows 8 environment, and what I want to be able to show you real quick is the Shift F10 option and the fact that you can break in here and actually see whether or not your system is prepared for UEFI. Then we'll go back and look at the security settings as well.
So Shift F10, right, from, I think everybody probably knows that from the Windows setup. Shift F10 will bring up a command prompt.
So I'm going to go to C Windows, CD to Windows. You have to type it right or else it won't work. Oh, okay.
So even though we're Microsoft employees and we were begging and pleading to get a copy of 8.1 so we could demo that today, no dice, we've got to wait with the rest of you. So midnight, what's today's date? Today is the 25th, so what is that? Midnight tonight, I'll be sitting online, waiting, stalking, looking for that release.
Okay, I believe that we...
And so I think what Alfred's trying to do here is he's just trying to get to a point where you can see how the partitions look once you've booted up.
Yeah, so normally you'd be able to see the partitions. We've wiped the partitions out, so let's see if I can...
The joys of demoing.
There we go.
There we are.
I'm going to go take a look here.
All right, should we jump into MDT?
Right, so the disk was wiped out. We don't have the data on the disk. I wanted to show you the logs itself and set up account.logs, and the data would actually show you what the partitions look like and what's actually loaded
So
on
what is that setup account.log?
It basically tells you how the system is loaded and whether or not it checked for UEFI itself, and it will tell you that UEFI has been installed in the system. So,
and that's located on C, Windows
Panther location. So again, this drive was wiped out, so this is probably why you're not seeing a whole lot of data on here. But what happens, just like we saw earlier, is once you start the build, it will wipe that whole system out and actually reformat it as UEFI by default. There's nothing you're going to be able to do with it. I'm going to, and we won't start now because I want to show you the other half of this, which is using it for an MDT-based build.
Okay, so I'll jump back over to our demo box here. Let's see. Okay, so we're looking at MDT 2012. This is our workbench. So we're going to take a look at a task sequence. We're also going to talk about how MDT is able to ascertain if your machine is able to deal with UEFI or CSM. So there is a task sequence variable. It is called isUEFI. isUEFI is what is used by the task sequence. Now, it's important to mention again, I mentioned this earlier, but we'll talk about it just to drive this point home. isUEFI will be equal to false if you are not running in native mode. So while the machine may support UEFI and CSM, if you're not running in UEFI in the BIOS, if it's not native mode, it's not going to report that way. So if you're running as both, that equals compatibility mode, MDT will say, oh, this particular machine is standard BIOS, and it will load that way. Okay? So that's an important piece. Now, another thing that's really important to know is that our MDT team has done a beautiful job of creating some scripts to automatically deal with this situation. So let me show you how that looks. If we go to our format and partition, you will see it says MBR, and it says that it's going to create one disk. Now, what's really important to know here, and we'll see the difference when we jump over to Configuration Manager, in the script that MDT calls to run this step, the logic is built in where it will automatically detect isUEFI, and it will automatically format the drive, as we saw earlier with the 3 partitions. You don't need to uncheck this. You don't need to change this. You don't need to do anything. If it detects isUEFI enabled or isUEFI equals true, it will automatically do that. Okay, so it's important to just get this one there. Yes, it doesn't, yes, we don't see anything that says isUEFI. That's because it's happening in the magic of the script in the background. So I want to start off our light touch. and I'm going to show you from the log file what that looks like. All right, so what I've done is I've just kicked off a task sequence, and when I do that, immediately we get our mini NT folder, and we get our logs here. And we're going to take a look at ZTI gather.
So envision that you're running this on a machine that you're actually building, and you have to get into the logs themselves.
So I'm going to search for UEFI, and there it is. Is UEFI, it's now true, okay? So right at the very beginning, we now understand this machine is ready to receive a deployment that's customized for UEFI.
So again, make sure that when you're building your scripts, make sure that you've reviewed your configurations, that you've accounted for the fact that you will have devices that require UEFI-enabled configurations. By default, and I think you mentioned this already, but again, you'll see that it says MBR. It'll have 100% disk, OS disk configuration. But the one thing that we want to assure you is that it will take that into account regardless of what you do here. It will know that that system needs to be UEFI aware, and it will go ahead and format it that way, just like the Windows 8 CD does itself as also. Question? The question was, wouldn't you do, in the task sequence, you want to go back to it?
Yeah, so
The question was if in the task sequence there's an option to select standard MBR or to select GPT disk. So that's a very good question. The reason, so one thing we didn't mention is it's there for you to be able to customize as you need. What we're saying is by default, this is what it does. If you need to customize it so that you can have multiple disks, or if you need to have disks that are based on a different layout, you know, having a BitLocker drive, having a recovery drive, having a specialized drive that you need, this option's still there. You can drop the GPT. In addition,
but by default,
right,
you don't need to.
it's just
Exactly. So
Repeat the question.
the comment was because of the is UEFI variable, if that's set to true, will it automatically format the drive appropriately? And the answer is yes. So you don't need to change anything here unless you'd like to customize your layout. If you leave it as is, if UEFI equals true, it will automatically format it for UEFI. All right. So we'll switch back to our PowerPoint. So with MDT 2012 Update 1, the MDT media and ISOs are created to deal with CSM or UEFI. So you get that immediately. You don't have to do anything special. It's automatically created. And this ties right into that whole idea of the scripts have the magic built in. You don't have to worry about it. Everything you need that Alfred showed us in that demonstration, copying the EFI folder and the .EFI files over, that's all created for you in the typical place. We're used to seeing it in boot. It's there. So you don't have to do anything special. It does, in fact, detect UEFI natively, like we said. It does the GPT configuration. It does the partition creation. But let's talk about a computer refresh scenario. So this is important because everyone wants to know this, and we get asked this a lot. As far as refresh is concerned, if you're running a computer on CSM, so you have your current infrastructure, and most likely it's all running in the compatibility support mode, and you want to change over, you're going to be deploying Windows 8, and you'd like to make use of UEFI and Secure Boot, you need to wipe the machine. So this is why we say USMT is your friend. So what we would need to do is utilize USMT, migrate the user settings off of the box, transition that box into UEFI native, and then place an operating system down on there as if it's a bare metal machine.
Yeah, I mean, the key, again, is you want to ensure that you're protecting your user's data. And that needs to be copied off to a location that is secure and that can actually be transferred back once you're complete.
Okay, so we're going to transition into Configuration Manager. Now, all the things, you ready?
Yes.
Okay, actually, we'll take a slight detour here, and we'll give Alfred back the demo screen.
So this is going to finish off. Ignore this. That's because I shut it off. I'm trying to show the boot. All right, here we go. So now we're going to, before we talked about the Windows 8 formatting, I'm going to use just the normal MDT configured Windows to Go device to actually do the boot process. And we'll see the difference here in the boot process. Can you see my
You know what? We've officially arrived. Can I get a round of applause from everybody? That was a blue screen, folks. Come on. Yes. Wow. I think we deserve a kudos on that one.
Don't listen to me.
That's fantastic.
It's the only thing I said. No blue screen. No blue screen. So again, here's my passport disk. That's Windows to Go device. I have all of the deploy files in the FAT32, the boot files in the FAT32, and the deploy files in the NTFS partition. From there on, it kind of loads and starts the actual build of the operating system, or the load of the configuration files that we need for the MDT. Again, I use my deploy media option. If I had a network option, I could actually have it configured to use Pixie as long as the WDS server is configured to support Pixie. Again, we recommend the Server 2012 option. And this works just as well. It allows you to actually install the requirements, the required files, the drivers, all of that, just like you do with a normal disk, but it does it for a UEFI-based system. I did skip one more. So processing. So same thing here. It goes right through, no problems, and you can then select. The screen is terrible. You can select your operating system and move forward with the actual build of your system. There's options where you can actually select to say, I want to.
So why is this important, Alfred? I mean, I just want to make sure we drive home the point that you're running the entire deployment share off your Windows to Go disk.
Exactly. And a lot of people have had challenges trying to do it because they didn't realize that FAT32 was required and having to get two different disks. So this is important to just understand that this becomes an element of what's needed to ensure that you're actually going to perform your Windows 8 deployment securely. Now, and I mentioned the word securely. You do not have to turn off Secure Boot to make this work. Some people think that Secure Boot will help them by turning it off. That'll help them kind of move forward. You don't have to do that.
So it doesn't prevent reloading the operating system?
It doesn't prevent reloading the operating system. Very important piece to know. So from here, you move forward with your actual deployment, and you kind of move forward with the rest of the build.
All right, so let's jump back to Config Manager. Okay, so the same things that we discussed in MDT are definitely going to be true here in Configuration Manager. As we jump and take a look at the task sequence, we'll see that there's a bit of difference. We don't have exactly the same script magic in the background, so we'll take a look at that. But the same things that we talked about as features dealing with UEFI are going to be true here. So let's jump into our demo. And I'm going to swing around here and get us into our virtual machine, which is Configuration Manager.
How many people are using OSD deployments for deploying systems? Wow, that's quite a few people. So how many people have run into the challenges with UEFI deployments? That's about half the people have.
Okay, so this is a standard. I pre-created it just because we know that task sequence takes a little while. We have several steps, so I pre-created one. But this is a standard task sequence. Within this standard task sequence, we're going to look at some specific pieces as we go down to almost there. Here we go. Format disk. We can see that by default we have these several different options. This is the option specific to UEFI. Now here you'll notice that we're not leaving it default MBR. We're actually gone in, we've specified the partitions that we want to create. So this is the difference with MDT and Configuration Manager. Here there is no script in the background that will automatically do that for you. We put it into the task sequence so that you will check and see using ZTI Gather if that machine is enabled to do UEFI, and based on that task sequence variable, we'll format it appropriately. The variable here is called SMSTS boot UEFI. So it is different than what's in MDT, and that's what we're using. So if it's true, then we're going to go forward with these partitions that we've created inside of the task sequence.
Can this also be edited as well?
It can be. So if in fact we've decided that we want to put our recovery image on the machine, we would do that right here. Now this is also a little bit confusing because we're creating multiple partitions. So I'm going to scan down here to the install. Notice that we have set OS disk. And if we go to the properties, we've set the partition name as OS disk. We have 4 partitions on this task sequence. We've set that partition name. Now if we come down to install and we look at our apply operating system image, a lot of times in the older days we would just say, okay, just use the next available formatted partition. We don't want to do that here. We need to make sure that it actually uses the partition labeled OS disk. Now all this is done for you when you create the new task sequence. It's already there. I just think it's really important that you understand this bit, because as we get into customizing our partitions and our images and doing things, it's important to understand that big difference from the way that we've done things until now.
Well, and just to stress the point again, if you do not label that with the variable name of OS disk, you run into the chance of it trying to install on a specific disk that isn't the OS disk. So it's a way of protecting any customizations you make to your disk layout.
So if we jump back up in the task sequence, we're actually looking at format and partition steps by operating system. So if we're using Windows 7, Server 2008 R2, this functions differently. If we jump down, you'll see that there's Vista and Server 2008. And that looks different too, the types of partitions that we're creating. And we're going to go ahead and take a look at the variables again. So if we talk about, I think we briefly touched on it already, the partitions. We have the WinRE partition. We have the EFI partition. That's where the EFI boot stuff goes. That's what makes the operating system come alive. We have the MSR, and then we have the OS disk. Okay.
Okay, switch screens, please.
So we're going to let Alfred talk a little bit more about some additional UEFI information.
Okay, and we're going to go into this a little bit more details about what you'll see in terms of what you get with UEFI, the benefits, the much more optimized infrastructure that you've created, the much more optimized system that you've created. So, you know, with the introduction of UEFI, we see suboptimal boot times just, you know, absolutely much quicker than we've actually seen before. We've gone from, you know, 15, 20, 20-second boot times all the way down to, 10 seconds. I mean, I think it's more than that, but depending on the type of device you have, the boot times have been just much more optimized. The fact that you're loading a larger buffer IOs to ensure you're no longer using interrupt 13, interrupt 16, interrupt 19 with the assembly code that you had before. Now you're actually just calling it a larger, just a larger memory. It can actually use larger memory based on the advantages of UEFI. And the post time has been sort of cut down quite a bit. We're still looking for vendors to kind of come in and help us develop against that, the power on self-test to ensure that it doesn't take a whole lot of time. And a lot of this has happened because of the standardizations that we've done with UEFI in terms of how drivers load, how the different components are initialized, and ensuring that it doesn't take all that boot time. In addition to that, another aspect that will speed up your system boot times, and most of us should know this, is SSD disk, right? So in addition, if you're running this on SSD disk, you have an increasingly optimized process of booting your system. Just another piece of this. And then the hibernation file also has been optimized as well because of the large buffer IOs as well.
We wanted to actually provide you with some numbers, but it's difficult because we work with so many different vendors. It would be difficult to present that fairly to you, without singling out one particular vendor or another. But I will tell you my personal experience. I have a Lenovo X1 Carbon. It is an SSD. it boots up. Before I went through and made any changes, I would be looking at my login screen in 9 seconds. And then when I hibernate my machine, as I lift the top, I'm already seeing, before I've completely lifted the top, I'm already seeing my login screen ready for me to start logging in as I'm preparing that screen to be able to type. Very, very fast.
And many of you that probably have Windows 8 systems are aware of this. We have, again, the boot times that were recorded with some of the earlier versions of Windows 8 and UEFI systems. And again, these numbers are with MDT actually doing the work on the background. You see 40 seconds times to initializing the MDT wizard. Now the delay really is on the MDT wizard. For those of you that use MDT, that's where those numbers are coming from.
Right when you said that, we saw Niehaus look right up. What? MDT scripts? What? So actually, Mr. Mike Niehaus provided this information. We borrowed it from his blog. Thank you. And this is specific. This is specific to using MDT to load. So that's what we're seeing here. If we're using USB, MDT wizard, legacy boot 50 seconds, native boot 40 seconds. So just multiply this out by the thousands of machines that we deal with. And this information was captured quite some time ago. And as we get faster, more optimized hardware, I definitely think that it's worth a revisit to this. So I would say keep your eyes peeled for the Deployment Guys blog. There's a few of us internally that are working on providing some updated boot sequence timing for you.
There's also a session that's covering boot performance, and I believe a lot of us is covering that as well. So we're going to go into the secure boot. Now, how many people are familiar with what secure boot is and how it works? Kate? Secure boot is another feature that's provided as a UEFI specification. And you see that coming out with the 2.3.1 specification that you see, again, with the class 3 devices. It's not a requirement that Microsoft sets, right? It's a requirement it's a specification that's set by the forum, right? And
wait a second, hold on. So I've heard in the news that Microsoft is trying to lock out other operating systems because they created Secure Boot. Are you telling me that's not true?
Come on, seriously?
I thought everything I read on the internet is true.
Okay, so just to be clear, Secure Boot is really there to ensure that your systems are protected and prevent unwarranted applications or rootkit to actually load your system and cause issues in the pre-OS environment. Before
it does that with what?
It does that through certificates. It does that through the signing of the certificates, and it's just ensuring that those certificates are who they say they are. Again, it uses.
So if I understand you correctly, what you're saying is I need a digital
signature.
A digital signature so that my boot process, my boot firmware is recognized and accepted?
Exactly. So
okay.
You need to ensure. So Windows 8 comes with those signatures installed automatically. If you have a device, we've worked with the vendors to ensure that they have the right the right signatures, the right certificates on those systems. If you start tinkering around in there, we need to be careful not to remove those. And the beauty of this is if you need to load other OSs on there, they're also going to need to be signed, and they also have to have that level of security to ensure that they aren't also going to harm the system. The ultimate goal is to protect the operating systems and the applications that they run on top of. As we mentioned before, we're starting to see a lot more rootkit viruses written to affect the pre-OS environment. And once it takes over, you're pretty much having to reformat that system or come up with a way to get that data back. Okay? And in addition to that, a lot of the scripts, a lot of the programs that we've developed are now going to allow for things to be able to recognize what's running on your system.
Anyone using PowerShell? Anybody like PowerShell? Oh yeah!
So here's a quick example to see if you have a system that's already running a UEFI and Secure Boot, you can actually get those parameters and understand what that configuration is. In other words, what's the drivers, what's the grid, what grid's running, and what's on the platform key. Can we go back one slide, please? So didn't go too much into detail with this, but this again talks about how that certificate signing process is protected from the platform key, which is provided by the platform vendor, and then the key exchange key, which is also on that system as well. We have a signing database as well, DB, and a DBX, which is basically to have certificates or hashes that aren't allowed to run on the system to be stored there. So if you try to plug in a device that doesn't have the right digital signature, and it tries to access the system, if that certificate or that signing information is in the disallowed location, it will not load that driver. So things like option ROMs that don't have those digital signatures will have that problem. The good news is that if you do have the right certificates and the right vendor signed signatures, you'll be able to run those applications and those on those systems as well. And
it's just a different way of looking at it here. So we have the UEFI secure boot. This is the flow. So we have native UEFI 2.3.1, and we have verified OS loaders, right? That's important. We wouldn't want unverified OS loaders to kick off, and all kinds of havoc would ensue. And then it starts the operating system.
Okay. Yeah. Again, all your system. Anyone that has a Windows 8 Surface, by default, Surface and Surface RT, all have this as a feature, and they're running this way now. They're already on secure boot, and it's done purposely to secure the operating system. So another feature that isn't necessarily what we consider UEFI, but it's another way to protect the system, is measured boot. So measured boot, again, adds to the security of the system, ensuring that each component that's actually installed in that system can be verified and placed in the TPM to ensure that it's actually who they say they are in terms of the signed hash. So each additional component that gets installed validates the installation of the previous cache to ensure that it's the right thing, and then it continues moving forward. If at any point there's a problem with that process, it will literally flag up and say, we have an issue. And there's another feature called remote attestation, which requires, remote database or remote services to actually validate that what's being installed in that system is what it is, what it says it is. It's a validation process. Then another feature that you'll hear about in some of these other sessions is ELAM, or Early Launch Anti-Malware. Again, this...
I got to take a survey on this one. Has anyone heard yet of ELAM? All right, I'm really actually excited to see just a couple of hands, because this one I think is pretty killer. I'm excited about this.
Yeah, so again, this is another way to run anti-malware in the pre-OS environment. It protects the pre-OS environment in a way that it ensures that you have a complete boot process all the way from when you press the button to the time you're running your operating systems.
So your anti-malware software is able to take log files, find out what's gone on before the operating system boots, report it to the anti-malware software, and then take action based upon what it finds out. This is all before the operating system comes up. With Windows 8, we have the Windows 8 loader, which is digitally signed. We have the anti-malware soft start, third-party drivers, Windows login. So what we're looking at is the difference here between the Windows 7 and Windows 8, and you can see Windows 7, we have those couple of red arrows which show us, wait a second, there's an OS loader there that's susceptible to malware. We have third-party drivers that are susceptible to malware. Well, utilizing ELAM with Windows 8, you can verify those things, and you're not susceptible to those kind of attacks. All right, so Windows 8 platform integrity.
So this gives you a full picture of what Microsoft is looking for in terms of a full secure platform, all the way from the time you boot your system to the time that you're actually testing to ensure all the components are secure. So this is a secure solution that's being provided. And again, as we develop new ideas, new programs, new applications, UEFI becomes a vital part to that process and ensures that you can actually run secure boot options. Before we kind of move forward, I want to do one real quick process of actually booting the system from the reboot process all the way back up, just to time it. Now, how many people actually shut down their systems at the end of the day when they go home?
Literally shut it down, like turn it off, press the button, boom. Now, we have a feature, that basically is around keeping the systems on. So it ensures that your systems are, continuously run, always on, always connected feature. And the importance of this is more around the fact that you can ensure that boot time from, if you have to reboot your system, it's fairly quickly. You don't have to wait for the problems, any issues to happen. So the Hibernate file is also a good place to have that ability to speed up your boot times using UEFI. And to finish off, we also have Windows support for UEFI, and the fact that we have the ability to use multicast deployments, and like I mentioned, the fast boot and resume from hibernation. Very important piece that UEFI provides. And lastly, the rootkit preventions that we talked about, and network authentication.
All right, well, that's going to wrap up the session. This is the key objectives that we've covered. I hope that we've been able to answer some things about UEFI for you. I am going to ask if there's any questions. Since we've run right to the very end of the session, please come and see us after as we're closing down. I'm going to mention the surveys, and I know you're going to hear this 1,000 times. Please fill out the survey. Let us know how we did. We actually have changed our presentation based on your feedback so that we could kind of meet the needs of the masses. So please go ahead and leave some good comments.
So how many people are going to actually go back and start using UEFI now? Awesome.
Whoa, really? Congratulations, Alfred. Hey.
All right, well, thanks for coming out.
Thank you, everybody.
And enjoy Tech Ready, TechEd. You're up.